Alors, on va pouvoir y aller. Merci de votre attention.
So, hello everyone. Who in the room has already bought bitcoins? Oh, quite a lot. On Ethereum. Ethers. Okay. So, thank you. So, today I'll present the ROCKCHAIN, which is a startup developing a layer on top of Ethereum for data privacy. So, as Christophe explained, we're in the process of an ICO, which is a coin offering, which will start on 1st November. But I'll go more in details about it. The agenda of the meeting is first we talk about what is data privacy in the context of a blockchain. Then we talk about our technology. We'll be fast on the team, and we'll talk about the project challenges. About the ICO conditions also. What does it mean to do a crowd sale using an ICO? So is there anyone interested in creating a startup in the room? Okay, so it's a lot also, so probably you'll be interested in ICO proceeding. It's a new way of incentivizing investors to your project. So what is a data privacy challenge? First, as you might know, the blockchain now stores only public data. So it's a challenge for companies to put their own data on the blockchain. It needs to remain private. So that's what I explain here. Companies who want to work with blockchain, they don't want to put their data publicly. Even if you encrypt the data, the companies don't want the data to be on the public blockchain because, as you know, with quantum computing or any other technologies, it might happen one day that it will be able to decrypt those data. So actually, private data must remain local. You can't move them. That's why we call the company the ROCKCHAIN, because it's like rocks. You cannot move private data. And then companies are really obsessed about auditing everything, so they need to know who has access to their private data. And the blockchain is very good for that because it keeps tracks to who access your data, tracks if you have a document, you can put the hash in the blockchain and you have a trace of who's the owner of the document. So when you want to integrate, when you want to integrate Ethereum in a company's corporation, it's quite difficult because it's incompatible. It's not compliant with the company's like IT rules. So in companies, you have, like, for example, active directories, complex access right systems. And with Ethereum blockchain, you need to get access to many peers. It's like peer-to-peer networks, like BitTorrent. And you have a lot of traffic you can't control much. So it's quite challenging for companies to open their doors, their gates, to a blockchain node and to create some real application on the blockchain. That's the challenge. Then the companies like to know who are they talking to. But in the blockchain, it's not like this. You have a node, it can talk to everyone. Everyone can create a blockchain node on their own computer. So it's a challenge also. So basically, with all those challenges, we can say that it's not yet possible to include corporate data in blockchain apps. So as you might know, blockchain apps are running locally. It's distributed application. They have local web servers, and they communicate through blockchain transaction. It's not a server hosted outside of the computer. With this challenge in mind, we need to look also on the B2C side, I mean the consumer side. Usually when you accept conditions, for example, installing Facebook application, you accept a lot of things, maybe you're busy installing the app, but you don't remind what you authorized. But you authorize, for example, SMS access, phone access, even your camera and microphone access. So it's a bit challenging. And because the data science is moving forward fast, later you will probably have some more sensitive files like DNA information. And you need to protect those, we think. For the B2B side, which means more the company side, it's more about regulations. Regulators can't access private data. For example, not always. If you have a regulator working in finance on computing the risk of a portfolio, probably the client wouldn't like much the regulator's access to all the financial strategy. So it's a challenge to compute some risk metrics on data without knowing the data. But there's technology doing that, and we are doing that in ROCKCHAIN, so we'll explain. In the B2C area, a lot of opportunities happen with the handling of private data. You think if some robo-advisor can handle your very intimate and private data, they can give good advices to you without your private life being compromised. I think about health, for example, your DNA, or what you eat, or where you travel, or probably your email content. If some advisor on external artificial intelligence can access that without ever compromising the data, and you have a cryptographic proof it's not compromised, then you'll probably accept giving access to those robo-advisors. So that's the challenge of privacy in the B2C world. So computing some information on top of private data, it's possible since a few years with techniques like garbled circuit, which is more generally called multi-part computation. You can check on the net. It's a new area of research. It's interesting, and I'll give you a brief word about that. So now we are going into what we build in ROCKCHAIN. So ROCKCHAIN is about only sharing the essential. It means like a Dropbox, decentralized, and you give access to who you want through the Ethereum smart contract. You choose who has access to your content. So that's what I say that. And you also define your own rules when giving access to the content. And because there's a blockchain, it's always stored on the blockchain. It's never forgotten. You can have a proof that you send a file to someone or that you own your own file. So in the blockchain, there's a lot of industries interested in these features, which is called proof of existence. It means you own a document and you have to prove that you own this document at one point of time. And with the blockchain, it's very easy because the blockchain is a database with timestamps, and it stores hashes. So you just need to put your document hashes at some point. It's signed by your blockchain address, so you have the proof easily that you own the document. But you also can prove that you're the owner, intellectual property owner of a document, if you go on a smart contract and you sign the smart contract with your address, saying this document is owned to me. And you can transfer this ownership also. It's like a lot of blockchain applications are about transferring titles. For example, fund parts, fund shares, or for anything about loans. It's easy in smart contract to say, I will transfer ownership of some digital asset from my person to any others. So what is ROCKCHAIN? It's 3 pillars, technological pillars. So I already talked about the DAP box, which is a decentralized file system. It's a little bit like Unix systems, but it's peer-to-peer, decentralized. When I say Unix system, it means it has rights like Unix systems, and you can change those rights. You have the generic privacy engine. It's a JavaScript running on several nodes at the same time and doing private computation. I'll explain more about that. And the Dashrock is a reporting platform that can create BI reports in real time on top of Ethereum. So the architecture of ROCKCHAIN is like this. You have private nodes, which is a dApp box, and you have public nodes here in red that can interact with the private node and do computations. And those public ROCKCHAIN nodes, they work on top of Ethereum nodes. It's kind of extra layer on top of Ethereum. So if it's a bit complex, you can stop me and ask question in the middle of the presentation, no problem. Just to explain you the challenge of testing Ethereum. For our own test, we deployed a private Ethereum network with 14 nodes. And we had to configure those kind of configuration file on each node, meaning each node knowing about the others. It gets very complex, very fast. So now we developed a toolkit with a bootstrap node in order for people to test private Ethereum networks easily. So basically what the bootstrap nodes does is just sending the configuration files to all others, and you can add dynamically some nodes. So we'll open source this code for the community soon. So now we have the dApp box interface, which will be also open source after the ICO. And we hope to release a binary version end of the year. So basically, you're sharing some folders with peers, and the access rights are on Ethereum. And your share folders have a unique identifier, and it's creating a network of content, a little bit like IPFS, but in our case, it's managed with access rights. So it's basically if you're granted or not the access on the blockchain. So what we do when I say it's similar to Unix, it's because on some folders you can define some access rights. For example, we have 3 groups. We have your private network groups, which is a company. We have a group of authorized users, which is authorized users in a smart contract. And you have everyone, so it's public access. So with those 3 groups, you define read or write access, or execute access. In our case, read, you can download the data. Write, you can collaborate on the data. So we have merge modules going into the dApp box, so you can do collaborative editing on a file. But through the blockchain, I mean, when someone changes the files, the blockchain knows about it. And also, you know the right is on the blockchain. And execute is doing some computation on top of some data. So you will say, how can you do computation on a file? It's because we also have the possibility to define some schema associated to a file. So it's I want this rule to be active in the ROCKCHAIN. It's because the file is conformed to an Avro schema. And also you can define in each field of the schema which is read-only, which is writable. So you have a very thin approach to privacy with ROCKCHAIN. And this is interesting for companies to know what fields can be open or what fields should remain private. So here you have a few indicators about the dApp box performance, but you also will have indicators of your Ethereum nodes with the dApp box, because behind we are using Geth, which is the Ethereum client, and it gives performance about how your node will be dealing with Ethereum. As you might know, Ethereum is not always stable in transaction rate. You have burst, for example, when many ICO occurs. Sometimes I've seen that in September 14, the transaction rate was going up to 30 seconds to be valid, which is not the usual time. So you can go, for example, on fstats, on other websites, and have the metrics about how the blockchain is dealing with the current transaction rate, how healthy is the blockchain. I don't know how much time we have, Christophe. Yeah? 20 minutes, yeah. Maybe I don't go very much in those details to let you have questions later. But we have a block structure dealing with how we have the proof of documents. So we're dealing with document versioning in the DApp box. So for now, the people who knows Dockers, there's a union file systems. Docker is based on layers. Who knows Dockers in the room? Quite a good community, yes, very famous. So you know you have layers, and when you pull an image, you get incremental version of files, which is based actually on Unix union file system. So we're doing the same thing. You can have a proof of the incremental adding of some folder files. You don't need to prove everything. So it's interesting in proving your document because you can prove a version of a file. And we are also linking files together. So you can say, for example, I have a master documents and you have dependent documents if you're doing, for example, a factory design. And you can prove which version of dependent documents is linked to your master document. So it's more document management with proofs. The DashRock is the reporting platform. So we're using open source components like fslurp. And as you might or might not know, it's difficult to have a good dashboard real time in the blockchain, Ethereum. So that's what we try to build, to download in binary forms all the blocks of the blockchains, to filter the blocks who are no valid transactions, and to be able to display in real time some information about any smart contract. So for this, we're using Druid.io. I don't know who's knowing Druid.io. No? It's a column-based database dealing with big data in real time. So we did a test on several smart contracts. So in the DApp box, you have ownership smart contracts. It says you're giving the ownership to someone else of your file. So I don't know if you can read from it, but you see that giving the ownership of a file to someone is quite easy in Solidity. Solidity is the programming language of Ethereum. And I think if you're a developer, you can go and write Solidity smart contracts. It's not, the difficulty is not writing Solidity. It's deploying and testing and understand gas constraints. Because where you write Solidity code, when you deploy, you have to take into account that it costs some gas, which means you have to buy gas for that. So we have also the proof of transfer smart contract. And here are the reporting we are able to do. So we took the smart contract ownership and we displayed how the ownership was changed for a file. So here is the ownership change from one owner to the other. So you can see that we have a smart Ethereum addressing I'm the owner of a file and I give the ownership to someone else. And then you have the graph of the ownership transfers. Okay, same thing for proof of existence. You can see that it's quite easy to prove that you own a document locally. On the proof of transfer also, is proving you transferred the document to someone. So here's a little bit some reports we can do with the DashRock. And now I'm going to talk about the GPE, the generic privacy engine. The difficulty is about doing private computation on private data. And we had a lot of frameworks doing that, but it's very opaque and complex code, sometimes near assembler language. So what we did is we wanted to do it easy for all. So we did it in JavaScript. So you take the GPE, and that's a unit test from us, and you just add some notation, for example, in and out, and that's it. In means it should remain private, and out is this data can go outside. So here I'm doing a matrix multiplication, and because my two first matrices are in here, they will always remain private on the DAP box. And what is going out is the result, because I said it was out. So this is it. With GPE, you can code JavaScript, any algorithm you want, and then you have a private computation and display the result you want.
Fini?
Non, non.
Et 25. Il reste 10 minutes maximum.
Il reste 10 minutes?
Ah ouais, à peu près. Ouais. Et c'est éteint, comme tout à l'heure. Voilà, petit problème technique, comme tout à l'heure.
Il a claqué, hein. Les BNQ, c'est pas mal. Hein.
Ouais, voilà, c'est ça. C'est ça que j'essaie de brider.
Sébastien,
Ouais.
we have an international question
Okay.
from Rostan Kezol.
Yes.
I didn't understand what is kept in the blockchain, private documents on a public registry. Another asking is how we keep privacy by sharing everything. What is kept?
So what is the first question?
What is kept in the blockchain? Private documents?
No, we don't store anything in the blockchain. Everything is private, and we store only hashes or computation results.
And is it on a public registry?
Yes, it's on Ethereum public registry for the proofs.
And so,
Yeah.
and so how we keep privacy by sharing everything?
We are sharing only the links,
Only the links, so,
never the data.
okay.
So of course, if you share, you have read access to everyone. So everyone has the information, but it's not stored on the blockchain. It's like a BitTorrent. They have access to it, but the blockchain stores only the proof of transfer.
Okay, thank you.
Welcome. Okay, I'm getting back to the GPE. So see, it was easy to do some private computation, some computation on private data. What does it mean? So this is for like developers. We are taking the algorithm and doing an abstract syntax tree out of it. This is the input of our GPE. And when it runs both on the private DAP box, on the public blockchain node, and it's running at the same time on the two locations. It's not us that invented the algorithm, it's called a Garble circuit. But the abstract syntax tree is run on the same time, and there's network transfer saying, okay, I'm on this step, and it's validating that it's on this step. It's creating a circuit where every input is encrypted. So for a hacker, it's impossible to change the code on the private node, because the public node is checking that the code hasn't been changed. See, if the logic has changed on the private node, the public node will say, oh, there's something strange, I don't agree, on your private computation, your computation on private data will stop. That's how it works. So it's running on two nodes, one public, one private. And the transfer between those is called oblivious transfer. So for the question before, what's happening is we are doing the computation, and the public node is sending the proof of computation to Ethereum node saying, okay, I have the proof that I did the algorithm unto this point in the abstract syntax tree, so let's prove it and put on Ethereum. So you measure how the algorithm has been evolved and processed using this kind of practice. So let me remind you that your code here is transferred into a tree. So each step of your code is a progress in the tree. And then you will find it again. The proof that you reach some nodes in the tree will be in the Ethereum. So with that, you can incentivize the nodes saying, my public node has really run the code. He needs to get some tokens for rewards because he did the job. So what we did is we took, for private computation, the best frameworks in open source, which is called Just Garble on FreeGates, which are supposed to be the best ones. And then we did some matrix multiplication. We are reaching the same time of processing. But we changed the algorithm and we wrote everything from scratch. And then we get 3 times less memory, which is good because it's very memory intensive. I'm talking about RAM in memory. And it's a good promise that we can do better computation. So if we get all this architecture working, we will be able to have smart contracts extended to private data. It means the workchain node can have logic on private data, and you can exchange with the smart contracts code and say, if some conditions on my private data are valid, please do some operation in the smart contract. For example, if the genome or DNA of some person has some kind of characteristic, do that kind of operation. So this is a big vision of ROCKCHAIN, being able to deal with private data in the global distributed computation framework of Ethereum. Because we think application running just on public data is very tiny, actually. The real value of data is private. So if you have a global network of computation like Ethereum, which is very good, being able to access the private data of users or companies, probably the market will be much better than today. Why? Because you look at cloud services market, it's already a very big number, 250 billion in 3 years. But it's only for one company at a time. There's no offers in this that takes several companies that would like to exchange documents, to do computation together on data sets, to do shared machine learning. So we believe in this big market of cloud services. There's a share that will be collaborative, and that the blockchain will be the key. So we are currently doing our ICO, preparing our ICO, I mean. The contract is released now, thanks to Christophe. And then we are launching our ICO on 1st November to then be able to deploy all the architecture I'm talking about. Here is our team of developers, mostly except Melanie, which is our community manager. And then we have our advisors working on several aspects of business consulting. And our first application is about DNA, human DNA. It's built by an entrepreneur in the United Kingdom. And he wants to be able, like he says here, to query the human genome without revealing your privacy. Because if you give your genome file, then it can be copied everywhere, and then you don't control your identity. You have sensitive information, as you might know. And then querying this DNA is with the GPU approach is good. So, who is actually interested in ICO and looking what's happening in the ICO? Two or three, yeah. Okay. So there's only 3 in the room, so I'll be fast. For the ICO, the challenge is not to give too much token, to keep too much token. Yeah, I mean, you need to distribute the token evenly, so that there's no price manipulation. So that's what we're doing. We're giving 80% of our tokens, and our tokens will be used to run the ROCKCHAIN infrastructure. So it's a public network. So the token owners own the infrastructure. And most of our proceeds go into our R&D. So please contact me if you're interested in joining. Yeah. So that's it. I invite you to go on our Slack, to check our Twitter, and then we can start the questions. Thank you.
So again, we have Rostan who complete his first question. It's what is the difference between your product and AXA smart contract? AXA.
I don't know AXA smart. You mean the insurer?
I think so.
Well, I don't know what they're doing, so I can't answer. Can you give me more details? Okay.
Yeah, I will change. Just, for example, do you have? It's interesting to understand how ROCKCHAIN will use computation on top of Ethereum. It's interesting because already we have a lot of problem with regulation. I'm talking about GDPR. General Data Protection Regulation. So here, just one question, Sébastien. So with your solution, we could use a ROCKCHAIN to manipulate this kind of data in compliant form with GDPR.
Yes, indeed. GDPR is about locating the files in a systems. So with that box, you prove that the file is somewhere in the IT systems. So you have with the DashRock, you have a map view of where your file is located, and you can also view the transfers between that box and knows who did the file transfer. So it's a history of any file exchange. Yeah.
Okay, so I can have the map, the overview of where my data is going, who use it, and this kind of information. So as explained before, just to make the parallel with my definition on and my explanation on blockchain technology. So here, public blockchain, everything is on blockchain. So you can create, a top a protocol, many protocols on top of public blockchain to create some services. Here, ROCKCHAIN creates a data, privacy services that use the power of blockchain technology. So, just one question related to it's my last, sorry, related to your ICO. So, just to explain why you decide to distribute 80% of the tokens. Because, as you know, in general, in ICO projects, only a maximum of 60% was distributed. So why do you choose that? I think it's important to tell us, because I just want to know that.
The global idea is we don't want to have any possible impact on the price as a team. So we want the price to be fairly distributed with the demand, and we shouldn't be able to impact the token price anyway. So that's why we only keep a minority part. Yeah.
Okay, thank you.
Yeah. A question?
Hi. Thank you for your intervention. I want to know more about the algorithm used in the blockchain innovation. Because you told us that when there is exchange of information, it's like a public key after a private key. This is not the same with RSA arithmetics.
Sorry, I have difficulty to hear you.
Okay.
Yeah.
I told that I want to know more about blockchain arithmetics, because when you told us that when there is information exchange, it's like a public key after private key. Yes, I think that this is the same than RSA, if you think.
Okay, about signature, yeah.
Okay. I want to know the difference between this arithmetics and RSA arithmetics.
No, of course, you have a private key in the blockchain. With that, you can sign your message, and other people know that your message comes from you, from that private key, because there's also public key. So it's used the same way. It's the same private public key algorithm. But it's extended to smart contracts. So you have distributed logic running on several nodes at the same time. And people can interact with this logic using their private keys and signing operation on it. So that's the blockchain, yeah. The smart contract blockchain. Yeah.
Okay. Also, you told us that the Ethereum is used to develop a tool track. A tool track.
I didn't catch your phrase.
You told us that the Ethereum is used to develop a tool track.
To develop what?
A tool track for make exchange of information between.
Access rights or?
Exactly.
Yeah, we're storing access rights on the.
Okay, but how does it work?
I shown the smart contract. So you define for each folders on the DApp box which smart contracts you give to which group of people, and that is public information. So you know publicly who has access to which content. Okay.
Thank you.
Yeah, thank you. Okay, no other question? Huh?
Hello. You said that everybody can see what we can do in the blockchain, but I have one question. The question is that how everybody can know that? Do they receive some notifications?
Basically, no. They need to write their own tool to know what's in the blockchain. You don't have notification. You have logs if you want, but it's quite difficult to use it. So that's why we're doing the dash work. We need to put some BI reports to know what's what's really happening on the blockchain for every smart contract. But you can still view it in some blockchain explorer online. And you type the smart contract address and looking at transaction, and you can understand what's happening, but it's very technical.
And you've talked about querying human DNA, and you said that he couldn't be copied anywhere. But the question is, how do you know that? How do you know that he won't be copied anywhere? With what kind of file?
We know it because the data remains local and is not exchanged. So the user only authorizes some computation. For example, let's say you want to know if you have a sleep disorder, and then you authorize some external script to test this on your DNA, but you don't give the file. And so you're sure that you have the result without giving your DNA for free.
Okay, but if we put all the files on the blockchain, someone can copy
No,
the
it's
file.
not on the blockchain. It can be on your mobile phone. You say
Okay.
you have your DNA on your mobile phone, and then you get a request. For example, an application will say, this laboratory wants to test your sleep disorder. Do you agree? Yes, no. You say yes. It does the script, and then gives the results to you on the laboratory, but the file is local.
Okay, thank you.
Yeah, thank you. Well, no more questions, so thank you, everyone.